Hi, I'm Jacob, and today I'm going to be talking about percent composition and empirical formulas. The percentage composition of a compound is the percent by mass contributed by each element in the given sample. Calculating the percent composition of a substance has many uses in chemistry. It can be used to determine the purity of a substance. One can compare the calculated percent composition with the experimental percent composition. If these values are close, then the substance is more pure. Chemists can also use percent composition to determine what an unknown compound is. In an experiment, one can determine the percent composition of an unknown white powder. This composition can then be compared to known compositions of white powder such as sugar, baking soda, salt, or cocaine in order to determine what the substance is. The percent composition of air is shown in this chart. As we can see, the majority of air is made up of nitrogen, about 78%, followed by oxygen at 21%, and the rest is an assortment of other gases. Percent of each element within a compound. The percent composition of a particular element within a compound can be calculated using this formula. The percent of that element equals the number of atoms of that element multiplied by the atomic weight of that element, all divided by the formula weight of the compound, multiplied by 100%. The number of atoms is the subscript next to the element. The atomic weight is the mass of an atom of the element, which is measured in atomic mass units. This is the number below a given element on the periodic table. The formula weight of the compound, also known as the molecular mass, is the combined atomic weight of all the atoms of each element in that sample. For carbon dioxide, there is one carbon atom surrounded by two oxygen atoms. The atomic weight of carbon is 12.01 AMU, and the atomic weight of oxygen is 16.00 AMU. The formula weight is 12.01 plus 2 times 16, because there's two oxygen atoms, which equals 44.01 atomic mass units. An example of percent composition. When asked to determine we are asked to determine the percent composition of C12H22O11. Using the previous equation, we can follow these steps. The percent of carbon equals 12 atoms times the mass of 12 AMUs divided by 342 AMUs, which is the total formula weight, multiplied by 100%, which equals 42.1% carbon. The percent of hydrogen can be calculated by multiplying 22 atoms of hydrogen by the atomic mass of 1 AMU, all divided by 342 AMUs, multiplied by 100% equals 6.4% hydrogen. The percent composition of oxygen can be calculated by multiplying 11 atoms of oxygen by the atomic weight of 16 AMUs, all divided by the formula weight of 342 AMUs, which equals 51.5%, multiplied by 100%, which equals 51.5% oxygen. To check if this percent composition is correct, we must add all of the found percentages together and make sure they equal 100. As we can see, 42.1 plus 6.4 plus 51.5 equals 100%. As shown by this percent composition graph, this compound is sucrose, which is table sugar. Empirical formulas. If one knows the percentage composition of a compound, then the empirical formula can also be determined. This is a formula giving the proportions of the elements present in a compound in the lowest ratio, but not the actual numbers or arrangement of atoms. It is the simplest, most reduced form of a compound, and is often different from the molecular formula, which is the actual formula of a compound based on molecular weight. Determining the empirical formula. Right here is a chart that shows the steps for finding the empirical formula of a compound. The mass percent of the elements is given. If we assume it is from a 100-gram sample, we can simply change each percent into grams. Utilizing molar mass, we then find the moles of each element by dividing the mass by the atomic weight of the element. Next, we must calculate the mole ratio between the elements. From this, we have the empirical formula. The subscript next to each element in the empirical formula is its relative molar ratio. An easy way to remember this process is to use this rhyme. Percent to mass, mass to mole, divide by small, multiply till whole. Divide by small means to divide each mole value by the smallest mole value. The last step, multiply till whole, is only used if the divided number is not whole, meaning it has a decimal place that is not within a tenth of a whole number. Putting it all together. The percent composition of C12H22O11 was determined to be 42.1% carbon, 6.4% hydrogen, and 51.5% oxygen. By following the previous steps, we can find the empirical formula of this compound. First, we must change all the percentages into grams, as shown here, assuming it is a 100-gram sample. So there are now 41.2 grams of carbon, 6.4 grams of hydrogen, and 51.5 grams of oxygen. From these masses, we can then calculate the number of moles of each element. 41.2 grams of carbon divided by its molecular mass of 12.01 grams yields 3.43 moles of carbon. 6.40 grams of hydrogen divided by 1.01 grams of hydrogen equals 6.34 moles of hydrogen. 51.5 grams of oxygen divided by the atomic weight of 16 grams oxygen equals 3.22 moles of oxygen. Because 3.22 moles of oxygen is the smallest mole value, we then divide each of the other mole values by this number. 3.43 moles of carbon divided by 3.22 equals 1.06 moles, which is about 1. 6.34 moles of hydrogen divided by 3.22 equals 1.97, which is about 2. And 3.22 moles of oxygen divided by itself is, of course, 1. Because these values for carbon and hydrogen are reasonably whole, meaning they are within 0.1 of a whole number, we do not have to multiply until whole. These rounded values are the approximate number of atoms of each element in the empirical formula, which are written as subscripts. Therefore, the empirical formula of C12H22O11, or sugar, is CH2O.